Hey folks, welcome to another set of 8th grade science video notes. Today we're going to be learning about the water cycle. By the time we're done here, you should know enough about the water cycle to develop a model that describes how the water moves through Earth's systems and that the sun and gravity are the sources of power for this cycle. So, just what is the water cycle? The water cycle is the process by which water is circulated between the Earth's oceans, atmosphere, and land. There are 4 main steps to the water cycle: evaporation and transpiration, condensation, precipitation, and runoff or infiltration. We'll talk about these more specifically soon, but here's a quick summary. Evaporation and transpiration are the 2 ways in which liquid water turns into a gas and becomes a part of our atmosphere. Evaporation and transpiration both require energy in order to turn the water into a gas, and that energy comes from the sun. Condensation is when that water vapor, the gas, turns back into a liquid. This occurs when the water vapor cools back down in the upper atmosphere and forms tiny water droplets, which form clouds. They're so tiny that they're able to stay in the sky without falling for a rather long time. At some point, they do tend to clump together and form water droplets that are too big to stay in the sky anymore. At this point, gravity pulls those water droplets down, and we get precipitation as rain, snow, sleet, or hail. Lastly, when that water or the icy particles land on the Earth, gravity can either help it flow over the ground into a body of water for storage, or soak into the ground into an underground water storage area. Those 2 scenarios are called runoff and infiltration. From there, the liquid water will find its way back to the surface, get warmed up by the sun again, evaporate into a gas, and repeat the whole cycle. It's important to note that the Earth's oceans hold 96.5% of our water. All of the oceans, lakes, seas, and rivers are responsible for about 90% of the water in our atmosphere. Though the water cycle involves both fresh and salt water, it's important to look at just how much of all the water on Earth is actually fresh water that's easily accessible to us. Of all the water in the world, only 2.5% of it is fresh water. Of that 2.5%, 68.7% is stuck in glaciers and ice caps, and 30.1% is stuck in the ground. That leaves us with just 1.2% of our 2.5% of all water that's accessible on the surface of the Earth. Of that 1.2%, 69% of it is stuck in the ground ice and permafrost, leaving us with just 31% of that 1.2% that we can easily access. If we do a little bit of math with those numbers, we can see that only 0.009% of all the Earth's water is fresh water that's easily accessible to us. Now, when we talk about pollution later on, keep that in mind. Of all the water in the world, that's all we can use, so it's important to do our best to keep it clean. All right, back to the water cycle. Let's talk about evaporation. As we said earlier, evaporation is when water turns from liquid into a gas. When water is a gas, we call it water vapor. Evaporation is the main way in which water enters our atmosphere. In this case, the liquid water on the Earth's surface will evaporate and turn into atmospheric water vapor. The sun is the driving force behind this evaporation because it gives that water extra energy. When the sun hits the water, its radiation heats it up and causes the water molecules to move faster. The faster they move, the easier it is for them to leave the surface and go from the liquid state to the gas state. There are other ways in which water can be introduced into our atmosphere. Sublimation is when solid water, or ice, on the Earth's surface jumps directly from a solid state to the gaseous state, skipping the liquid state altogether. This happens when it's very cold and the snow or ice can't melt into a liquid. Transpiration is when water that's underground gets sucked up by the roots of plants, and then that water evaporates through the leaves of those plants. While these 2 ways are not the most prominent way in which water enters the atmosphere, they're still very important to know about. Once the water is in the atmosphere acts as a highway, transporting the water from place to place. Condensation and precipitation both take place in the atmosphere. Generally, the higher you are in the atmosphere, the colder it is. As our water vapor moves higher into the atmosphere, its particles slow back down. As they slow down, they start to bond together, going back into the liquid state and forming very tiny water droplets. We call collections of these tiny water droplets clouds, or if it's low enough to the ground, we call it fog. Those tiny water droplets eventually come together to form larger drops of water. Once they're too big and too heavy to continue to float in the atmosphere, gravity pulls them back down to Earth's surface. This is called precipitation. Precipitation can come in the form of snow, sleet, hail, or rain. When precipitation falls, it creates rivers, puddles, streams, and such. We call it runoff. Either that precipitation or liquid water from melting ice caps or glaciers will flow over the Earth's surface. Gravity pulls it down into a larger body of water, like a lake or an ocean. It then stays in that body of water until it re-evaporates and starts the cycle all over again. When the ground's permeable enough, the precipitation will soak into the ground as much as it can before it starts to flow over the ground to other places. This is called infiltration. The water that's stored in the ground is called groundwater. A lot of times this water is part of a large underground aquifer. Aquifers are just large collections of water underground, usually in a permeable rock layer. These are often great places to drill a well. The last thing you need to know about the water cycle are the three states of matter and what we call the transitions between each of them. Gases have the highest amount of energy, then liquids, then solids have the least. So when we move from a state of higher energy to lower energy, we have to cool that water down. We heat the water up if we want to add energy and move to a higher energy state. The three transitions that require additional energy are melting from solid to liquid, evaporation, liquid to gas, and sublimation, solid to gas. The three transitions in which energy is reduced or taken away are freezing, liquid to solid, condensation, gas to liquid, and deposition, gas to solid. You don't often think about deposition or sublimation, but the two easiest examples are dry ice and frost. Dry ice sublimates. It goes directly from a solid chunk of CO2 to CO2 gas. This is often used for Halloween effects to create a fog. If it helps to remember, sublimation starts with an S, and it starts as a solid and then moves to a gas. As for deposition, you don't really get to witness it, but on really cold nights, water vapor in the air will go directly from a gas to a solid. This is what we call frost. You might say that it gets deposited onto the ground. Well, that's all for today, folks. I hope that you're able to learn something today and that you now know the four main steps of the water cycle and the two things that power it. Thanks for watching, and as always, if you have any questions, ask.